Welcome back, Dragons. This is the second part of Activity 3.2. We're starting with number 4. How do you think the distributive property will play a part in dividing expressions? Let's find out. This character makes a really good observation here. I know that multiplication and division are inverse operations, so I should start thinking in reverse. Consider the expression 4x plus 8 all divided by 4, which also can be written as 4x plus 8 divided by 4. First, represent 4x plus 8 using algebra tiles. Sketch the model you create. Well, I've created that model for us. Notice that these are not the factors. This is the inside. This is like the product. 1, 2, 3, 4 x's and 8 red tiles. So that is my original sketch. So you see me here. I'm going to sketch it here. So this were my algebra tile model. My 4 x's would be living in here. X, 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 and then my 8 singulars, I'm just going to draw it like that, would be there. Next, divide your algebra tile model into 4 equal groups, then sketch it. 4 equal groups, that would be that. That is 4 equal groups. That's going to look like, let me take care of all the different colors separately. Okay, so I've got my X's drawn, and then this one would have 2 of those red blocks tagged on. This is not drawn to scale. Okay, so that's 1, 2, 3, 4 groups. I'm going to zoom in on this so you can get a really good look at these pictures. All right, so this represented the 4x plus 8. Then they told us to cut it up into 4 groups, equal groups, 1, 2, 3, 4. Write an expression to represent each group from your sketches in Part B. Well, if one group is this, the expression is x plus 2. Verify you created equal groups by multiplying your expression from part C by 4. The product you calculate should equal 4x plus 8. Well, if I do 4 times x plus 2, because I should have 4 of these, if I distribute appropriately, I would do 4 times x plus 4 times 2, which is 4x plus 8. It's a match. Perfection. Let's keep moving. All right, let's consider the division expression from question 4. You can rewrite an expression of the form 4x plus 8 divided by 4 using the distributive property. 4x plus 8 divided by 4 would be 4x divided by 4 plus 8 divided by 4. Just like when you multiply, that the number outside the parentheses has to multiply by every number inside the parentheses, well, this is kind of like every number on top needs to be divided by the number on the bottom. So, although this is your divisor, this entire thing is your dividend. Each part of your dividend has to be divided by your divisor. Dividend, the whole thing, divisor. So once you do that, it kind of creates an interesting situation for you. You have 4x over 4. Well, 4 over 4 is 1. That's here, that they show here. Then you have this whole situation, 8 over 4, which can be simplified to 2. So you've got 1x plus 2. You can eliminate that 1 because we know x implies a 1, x plus 2. So this entire expression is this expression. It seems unlikely, but they are in fact equivalent. And I think we can all agree we would rather work with this one than this one. This one seems much more complicated, even though they would really result in the same value. Little side note here, to rewrite the expression, divide the denominator into both terms in the numerator. Every single term in the numerator has to be divided by the denominator. That's what that's saying. The model you created in question 4 is an example that shows that the distributive property can be used with division as well as multiplication. Consider the expression 2x plus 6y plus 4 divided by 2. This whole thing is being divided by 2. Use algebra tiles to represent the division expression. Let's see, we need 2x's, 6y's, 2x's, 6y's. I've not tried this before. Plus 4. Somehow that's not feeling correct. 2x's, 6y's, and 4. We need to divide it into 2 groups. Okay, well if I divide it into 2 groups, it would look like that. It would look like that, not these guys. So it would be 1x plus 3y plus 2. 1x plus 3y plus 2. So use algebra tiles to represent the division expression. We've got 2x's, x, x, got a bunch of y's, and there's 6 of them. I'm just going to draw a bunch right here. Here we go, y, 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 y. Then I had 4 of those red ones. Okay. Now, we would have to cut it in half. So that would mean that we would have an x, we would have 2 y's, 3 y's, and we would have 2 constants. And we would have this twice. So I'd do it again. Because altogether it would end up being the original expression. Alright, so there's my diagram. Let's see how this works out mathematically. Rewrite the division expression using the distributive property, then simplify the expression. Okay, so I need to divide every single term by this divisor. So 2x gets divided by 2. 6y gets divided by 2. 4 gets divided by 2. Now what would I be? What do I end up being? 2x divided by 2 is just x, plus 6y divided by 2 is 3y. Four divided by 2 is 2. Let's see if this, they say verify that your answer is correct. Does it match the model? X for an x, 3y for 3y, 2 for 2. Yes, it is correct. So, x plus 3y plus 2. This expression is the same as the one modeled by the algebra tiles. You're doing excellent work here. This is not easy stuff, so I'm very proud of you for sticking it out. Let's see how much more we got. We're almost there. We're almost done with 3.2. We're doing good. Zachary thinks he can simplify algebraic expressions that use the distributive property with division without using algebra tiles. He wants to rewrite 6 plus 3 times the quantity x plus 1, all divided by 3, in as few terms as possible, and proposes 2 different models. Analyze each correct model. All right. Here, he breaks this up into, this is a term, and then he pretends this entire thing is a term up here. Then he divides that side, and he divides all that side. Then he combines like terms here. Okay? Here, he does a little bit of order of operations first. He distributes the 3, rewrites the top numerator, then starts to combine like terms in the top. And the reason he does that is the top, the numerator is kind of treated like it's in parentheses. So what he's doing actually is allowed. So he's combining that 6 and the 3 to make 9. So you've got 3x plus 9. Then he uses that distributive property to have 3x divided by 3. Then the 9 divided by 3. He simplifies both sides. He gets the same thing. So let's put this into words. Method 1 divided the 2 terms, each by 3. The 2 terms being 6, and they're calling it like 3 times the quantity x plus 1 is its own term. It says this is a term, it's saying this is a term, and we divided each by 3. And then simplified each term. In method 2, we distributed the 3 to the x and 1. He simplified the numerator by combining like terms. Let's make that period. And then divided each remaining term in the numerator by 3. Then he divided each remaining term, which is the 3x and the 9, by 3. Lastly, he simplified. So, which method do you prefer? This one seems shorter. And it works out okay as long as you can see that the 3 up here can cancel with this divisor here. If you can see that this factor can cancel with this divisor, you're good. But naturally, for me, I want to do order of operations, and I want to distribute this and then do this method. So I tend to do this method, even though this one's simpler. So it really just depends on how your brain works and how much confidence you have in doing some of these tiny shortcuts. I wasn't trained to do these shortcuts, which is probably why I do it the long way. But you do whatever makes sense to you, because either one is fair game. That concludes 3.2, which I think is a fantastic lesson with algebra tiles. I hope you joined me this weekend for this lesson, and I appreciate your time.